Hey there, as we look at 4.7 today on parallel lines, we are going to look at a couple of things with this lesson. The first is the two objectives for it. And so that you'll be able to do the following. Be able to find the slope of parallel lines, and you'll be able to write the equation of a line parallel to and through a given point. And we're still focusing on the same two standards that we've been doing the last few days on FIF4 and FIF8. And again, we've talked about how those are dealing with interpreting functions and their characteristics. So first thing, remember from the announcement video, go and click on this link right here, this Desmos link here, and go and complete the parallel lines activity. Again, that will show you some ideas on why parallel lines are the way that they are. Again, it'll take you about 15 minutes to do that activity, maybe 20, but go complete it first, pause this video, go do that, and then come back and listen to my notes. So I hope you have gone and done the Desmos activity. If you haven't, again, I really strongly urge you to do that because I want you to get the full part of this lesson, because this is something that we would have done in class together if we had been together. So let's talk about why two lines are parallel. And so if you did the activity, you're going to see that two lines are parallel because of what? What was that last slide talking about? Two lines are parallel because they have what? The same slope. That's the only thing that matters when it comes to two lines being parallel. Because remember, parallels like railroad tracks, right? So these two lines will be the same distance apart no matter where I go along them and cut a perpendicular line through them. Now, we'll talk perpendicular later on in geometry, but you've learned perpendicular before. Remember, that's crossing at a right angle. And so this line is the same distance away from the very top of it all the way up top of the graph this way and all the way down below here. It's never going to get closer. It's never going to get further away. And the reason it is because those two lines have the same slope. And so like if I was to find the slope of these two, right? So I can start here, right? This line goes through, has a y-intercept of -3, and it goes through at this point here at 1, -1. And so this has a slope going up 2 and right 1. So the red line has a slope of +2. And if we do it for the blue line, we'll see the same thing happen. We can start with this point here, the y-intercept here, and then we go up 2 and right 1. And so my blue line has a slope also of 2. And so that's the key thing about this lesson today. If you get nothing else, parallel lines always have what? The same slope. Again, parallel lines always have the same slope. Again, if you get nothing else out of this lesson, that's what you need today. Parallel lines always have the same slope. And so let's look at just a couple of examples here of some lines, and we want to know what is the slope of a line that would be parallel to the line that we're given. So here's my original line, y equals 5x minus 1. Well, what would the slope be of a line that is parallel to it? Well, we need to first look at the original slope. So the slope of the first line, and remember this is in slope-intercept form, so remember the slope is in front of the x term, and so the slope of my original line is 5. And so the question becomes, what would be the slope of my parallel line? Now, this little symbol here, it's slanted, it's not an 11. If I wrote it straight up and down, it'd be 11. But if I, with the diagonal twist to it, it makes it the symbol parallel. And so what is the slope parallel? Well, remember that parallel lines have what? The same slope. And so the slope of the line parallel would be 5. So let's look at example 2. Y is equal to 1/2 x plus 3. What's the slope of the original line? Well, remember it's attached to the x, so that slope is 1/2. So what is the slope parallel to it? It's what? That's right, it's the same slope. It's 1/2. This is going to get very repetitive, but I want you to get this in your head, that parallel lines always have the same slope. I don't know how many times I'm going to say it in this lesson. Maybe you should count it up, and maybe I'll give you some house points or something if you can tell me how many times I tell you that parallel lines have the same slope. All right, let's look at example 3. This one's a little different because this one is not in slope-intercept form. This one's given in standard. So I've got to solve for the y. And so remember, if you're in standard form, this number here is not the slope. This number here is not the slope. You have to get it solved so it is in slope-intercept form so you can see the slope. And so remember, to solve from this to slope-intercept, we're going to subtract the x term across the equal sign. And so we get negative 3y is equal to negative 2x plus the 10. Or you could write it 10 minus the 2x, either way. But the key is remembering that once we get the y by itself, that the coefficient in front of the x is the slope. So now I've got to divide everything by the negative 3 to get the y by itself. So these will cancel. And so I'm going to get y equals negative 2 divided by negative 3 would be a positive 2/3. The x stays. Minus, because positive divided by negative, 10/3. That doesn't reduce. So this is the equation now in slope-intercept form. So what is the slope of this line? Well, it's the slope that we see here. The slope of the original line is positive 2/3. And so coming back to our original question, remember our original question is to find the slope of a line parallel to it. So what is the slope of a line parallel? Well, it would still be, again, remember, parallel lines have what? The same slope. So this slope is also 2/3. All right, so let's look at example 4 here. I want you to pause the video and take a second and try to solve this one for the y. All right, so if you solved it for y, let's see what you get. So we start with the 5x minus y is equal to 8. And so we're going to subtract the 5x from both sides. And so I get negative y is equal to negative 5x plus the 8. And again, I've got to get the y completely by itself. And so I've got to divide by the negative 1, because remember, there's a 1 sitting right here. Remember that the y is not equal to negative 1. The coefficient of y is negative 1. So I'm going to divide everything by that negative 1. And so we get that y is equal to 5x minus the 8. And so what is the slope of the original line? It is positive 5. And what is the slope of the parallel line? And again, I don't want that looking like an 11. I want it parallel. What's the slope of the parallel line? It's the same thing. It's 5 again. So again, kind of repetitive there, but I want you to get that in your head. Parallel lines have the same slope. All right. So here's where we get into the bulk of what this lesson's about, is being able to take information and find new lines. And so you see the direction here is to write the point slope form, and when we get to examples 7 and 8, it'll be to write the slope intercept form of the line described in the problem. And so pay attention to the information we're given here. We're told that this new line is going to go through the point negative 2, 5, and it's got to be parallel to the line given here, y equals 3x plus 1. And so remember that to be able to write the equation of a line, I need the slope and a point along it to plug it into what form? Point slope. So before I use this information, I've got to get the slope out of this. So what is the slope of the original line? Again, that's because it's in slope-intercept form. I'm going to just take this 3, so my slope is 3. And what is the slope of a line that is parallel? Remember, it's going to be the same, so it's also 3. So I've got my parallel slope, and I'm going to go through this point. And so I'm going to plug in to point slope, because I need a point and a slope. That's the whole point of point slope form. So y minus y sub 1 is equal to m times x minus x sub 1. And I'm going to label out here. This will be my x sub 1, y sub 1. and this will be my slope. I don't want to use the original slope. I want to use what I'm telling us is the parallel slope. Now, they're the same value, right? But the key is this. When we do perpendicular lines in geometry, I don't want you getting confused with using the original slope. Always use the new slope, not the old slope, okay? And so y minus y sub 1, so that's the 5, is equal to our slope times x minus the x sub 1, so minus -2. And simplifying the signs here, we get y minus 5 is equal to 3 times x plus 2. This is the final answer because it asked for it in which form? Point slope form. So now let's look at example 6. Again, I'd like you to pause the video for a second and try this problem on your own. All right, so this one's not exactly the same as the first problem, and I want to make sure you pay attention to this little detail. Again, we've got an order pair here. We're going to use that order pair in a minute. But look at what line we're being told to go parallel to. It's the line y equals 5. What are we missing in this line? Well, look back at the previous problem. This said y equals 3x plus 1. This problem just says y equals 5. We're missing the whole term that has the x attached to it, right? Well, remember what we did with horizontal and vertical lines back in section 3. Again, if you don't remember section 3, go back to section 3, and we talked about horizontal and vertical lines. So make sure you review your notes on that. This is y equals 5. This is a horizontal line, because if we graph y equals 5, it's going to go on the graph, and it's going to be a line going here where it crosses the y-axis at 5. It's never going to touch the x-axis because it doesn't have an x variable. And so what is the slope of this original line? Well, there's no x term. So what would make the x term completely go away and not be apparent anymore? When the slope is what? 0. And so what is the slope parallel to that? Well, the slope parallel is also going to be what? 0. And so I can plug in the point slope. Y minus the y sub 1 is equal to m times x minus x sub 1. And so this is my x1, this is my y1. So y minus the -1 is equal to 0 times x minus the 7. So simplifying signs here, we're going to get y plus 1 is equal to 0 times x minus 7. Now this is the one case when we have point slope form that we're actually going to simplify the parentheses, because what is 0 times anything? 0 times anything is 0. So I'm going to get that y plus 1 is equal to 0. And I want it to look like this. And so I'm going to solve for the y. And so subtracting 1 from both sides, because it said plus 1, so I need to minus 1 from both sides. I get y is equal to -1. Now, why is that the case? Why is y equal to -1? Why is that line coming here? Well, think about this order pair. 7, 1 would be 7 in x, and then 1 in y. So my point is there. It does cross through the point 7, -1, and that is parallel because they're both horizontal lines to the original line. Okay? All right, so the last two examples are going to be like the previous two that we just did. Except the direction is not going to stop us at point slope form, but it's going to take us all the way to slope intercept form. And so it's just going to be 2 extra steps to finish this off. But the first steps are the same. We're still going to take our information of our point. We want it parallel to this line, so I'm going to think about this slope. What is the slope of this first line? It's that m is equal to -2/3. And so what is the slope parallel to that original line? Again, parallel lines have what? Parallel lines have what? Come on, y'all. Parallel lines have the same slope. So this slope would also be -2/3. And I'm going to use this order pair to plug into point slope form. So y minus y sub 1 is equal to m times x minus x sub 1. Now you're probably asking yourself, why am I plugging into point slope form when the question asks for slope intercept form? Well, think about the information we have currently. I have, oops, let's scroll back down there. I have a point and I have a slope. So I need to plug into point slope. And then I can solve from there into slope intercept. So this is my x sub 1 and my y sub 1. So I'm going to get y minus negative 3 is equal to the negative 2/3 x minus 1. Now, the double negative here will go positive. Y plus 3 is equal to negative 2/3 x minus 1. Now, if I wanted point slope form, I'm done. But I want slope intercept form. And so two things are going to happen. Then this is the preferred order to do this. You could switch the order up, but again, with the work that I saw for 4.6, I want to make sure you do these in the right steps. And so negative 2/3 times the x and negative 2/3 times the negative 1. So we're going to get y plus 3 is equal to negative 2/3 x plus positive 2/3 now, because negative times negative is a positive. And then I want to get the y by itself, so I'm going to subtract the 3 from both sides. And this is where some of you are going to be like, oh my god, there's a fraction. And I'm going to say, oh my god, you're right. And y'all can deal with fractions. So 2/3 minus the 3, remember, put that over 1. Get our common denominator, which would be 3. So I'm going to multiply this by 3, which means I multiply this by 3. So I get 2 minus 9 is negative 7/3. So I'm going to have minus 7/3 out here. And that is our answer in slope-intercept form. Again, don't be afraid of the fractions here. They're not going to be difficult. Your brain makes them way more difficult than it really needs to be. That you can do these, y'all. Okay. Last example. It's going through the point 4,1 and parallel to y equals 5/3 x. Now, I want to point something out. This problem is very similar to number 6, except for one thing. In number 6, we had y equals 5. There was no x there. In this problem, we have y equals 5/3 x. So this 5/3 is what part of our equation? It's not the y-intercept this time, but it's our slope. And so my original slope here is 5/3, which means that my parallel slope is what? Remember, parallel lines have what? The same slope, so the parallel slope would still be 5/3. And so we're going to do the same steps. Y minus y sub 1 is equal to m times x minus x sub 1. And so again, I'm going to label here, this is my x1 and y1, and I'm taking this slope here. And so y minus 1 is equal to the 5/3 x minus 4. And so distributing this, y minus 1 is equal to 5/3 x minus 20/3. Not 20/12, because remember, this 4 is over a 1, right? Not over anything that would multiply to that denominator. And so now we're going to add the 1, plus 1, and plus 1. And so we're going to get that y is equal to 5/3 x. And I'm doing negative 20/3 plus 1. Remember, that's over a 1. So negative 20/3 plus 3/3, because I'm going to multiply both the denominator and the numerator by 3 to get my common denominator. And so that is equal to negative 17/3. And so I get y equals 5/3 x minus 17/3. This is the slope-intercept form of this line. So your assignment will contain these type problems on finding the slopes of parallel lines and also being able to find the equations of new parallel lines that go through a particular point. And so again, if you have questions, check out the Zoom chat or email me, and I hope y'all have a great day. But before you go, don't forget about the word of the day. And the word of the day is parallel. Again, the word of the day is parallel. P-A-R-A-L-L-E-L. Parallel. Y'all have a good one.